problem of the optional exam was finding the integral of dx over the square root of 4x squared plus 1. The method we use for this problem is trig substitution. And since it's a positive x coefficient and a positive variable, our x is going to equal tan theta. But since we have a 4 here, the best way to cancel it out is to make it tan theta over 2. So the dx will equal, the derivative of tan is secant squared theta, so it will just be secant squared theta over 2. And now we're ready to just put that into the equation. So the dx equals secant squared theta over 2, so it will be secant theta squared on the numerator, and we're going to bring the 2 down. And then the x is tan theta over 2, and since it's x squared right here, we're going to do tan squared theta over 2 plus 1. Alright, so we have to square everything in these parentheses. So it's going to be tan squared theta over 4 plus 1. So now our 4's will cancel out, so we can solve the problem like normal. So if we look here, what's in that square root now will just be tan squared theta plus 1. And we know that tan squared theta plus 1 equals secant squared theta by just our regular identities. So we're going to actually substitute secant squared theta. So it will be secant squared theta. Since there's only one value in here, we can just square root the problem. So it will be secant squared theta. We're going to take this 1/2 actually out of the integral because it's going to stay a constant. We can put it in when we're done. And the square root of secant squared theta is just secant theta. And secant squared over just 1. It's going to cancel this out and make this 1. So it's going to equal 1/2 to the integral of secant theta. Alright, so the integral of secant theta is ln natural log of the absolute value of secant theta plus tan theta. And the 1/2 is here, so we're just going to put it out here. And that would be our answer, but it's in terms of theta and we want it in terms of x. So the best way to do it is look at our original substitution. So x equals tan theta over 2, which would make it 2x equals tan theta, which would equal, so you remember SOHCAHTOA, opposite over adjacent, and then we're going to draw a right triangle. Okay. So the tan theta is here, and this is going to be our theta. So tan theta would equal opposite over adjacent. So we're going to do 2x over 1, so you can see. So the opposite would be 2x, and then our 1 would be the adjacent. So the hypotenuse using a squared plus b squared equals c squared would be 4x squared plus 1 squared, which is just 1, so we're just going to write 1. All right, and now we're ready to solve. So secant theta equals 1 sec over cosine, and cosine equals adjacent over hypotenuse, which would mean we'd flip it because it's 1 over cosine, so it would be hypotenuse over adjacent. So secant theta equals the square root of 4x squared plus 1 over our adjacent, which is 1. And our tan theta, like I just said, is opposite over adjacent, so it's going to be 2x. So now we can plug it in. It will be, our answer to this problem will be 1/2 the natural log of the square root of 4x squared plus 1 over 1, so we don't need to draw that, plus 2x, plus our constant configuration c, and that is our final answer.